Hey kids, Mr. Murray here, Mr. Murray's Mathland, and we are continuing looking at solving systems of equations with the third and probably best method, which is called elimination. And so we've learned about graphing so far and substitution, both pretty good methods, but this is probably the best of the three. And here's the deal. Take a look at these two equations here. Notice how the x's are lined up with the x's, the y's are lined up with the y's, and the constants are lined up there. Both equations are in what we call standard form, x, then y, then constant. And there's something special here that's going to make it all work. And that is, if you notice the y's here, that's positive 2y and that's negative 2y. They are opposites of each other, meaning they would cancel each other out if I were to add them together. So that's what I'm going to do with these two equations. I'm basically going to add them together. If I notice this is the case, I'm going to add these together to make one new equation. So when I do this, negative 3x plus 5x here gives me 2x. 2y minus 2y cancels each other out, leaving you with 0y, equals negative 6 plus 18 on the other side gives you 12. And here's your new equation, 2x equals 12. And that's just a pretty simple equation to solve. Divide by 2, and you get x equals 6. And obviously, to solve this system fully, you need to find the y-coordinate also. So I'm going to plug this value of 6 into one of my equations. It does not matter which one. It shouldn't matter which one. If one of them seems easier to you than others, go ahead. So I'm going to plug it into the first equation. So negative 3, and in place of x, I'm going to put 6 plus 2y equals negative 6. And now I should be able to solve for y. Just take your time. No silly mistakes here. So we get negative 18 plus 2y equals negative 6. Now I'm going to add 18 to the other side. I'll be left with 2y equals 12. Divide by 2. And you get y is equal to 6 also. So our final answer is 6, 6 if you want to answer with an ordered pair, because remember, what you are finding is the point, the coordinates of the point where these two lines would intersect if you were to graph them. So pretty good, right? Pretty fast. But remember what made it all work, and what made this so fast is this right here. The fact that I had opposites with the y's. And it doesn't matter, it doesn't have to be the y's, it could be the x's also, but if you have those opposites where they will cancel each other out, then that's what you're looking for. And then I just just added these two equations together to make one new equation. Okay, so let's see one more example here, and one that's a little bit more involved, a little bit tougher here. So if you can handle this one, you can pretty much handle them all. So take a look at this. Notice that this time the equations are not in standard form. You see you have 7y equals negative 4x minus 1. And maybe you're thinking, hey, I could use substitution, which you absolutely could. Substitution would work, but you'd have to divide by 7 to isolate y, and then you're going to have a bunch of fractions here. So I still recommend using elimination, but we do want to put this in standard form. So I'm going to move this 4x to the other side in this equation, and I'm just going to take a step. Don't want to try to do too much. And now I have my first equation I left alone, and this new equation at the bottom, the same equation but rewritten as 4x plus 7y equals negative 1. Once I move that 4x to the other side, right? And so I wanted to put it in that same order so everything lined up. Okay, so now take a look at this new way I have my system. I got everything lined up, but I don't have any opposites. I've got 6 and 4. I've got negative 5 and 7. If I add these together, neither variable will cancel out, and we don't want that. We don't want to make an equation with two variables. We need one to eliminate. That's why this is called elimination. So there's a few different things you can do, and I just want to show you that here. That here's really the big tip, is that you can multiply each equation by anything you want. So I'm going to try to make opposites with my variables. Now to do that, you could focus on the y's or focus on the x's. So just for example here, suppose you wanted to make opposites with the y's, because you have -5 and you have +7 there. Well, one thing you could do is you could multiply this equation by 7, and you could multiply this one by 5, because, skip ahead a couple steps, that would make -35y there after you multiplied by 7. And in the bottom, 5 times that 7y, after you distribute, you'll get +35y. You'll make opposites. So that would definitely work. But just to show you, it doesn't have to be the y's, because the last equation, the last system we did, canceled the y's. I'm going to cancel the x's in this problem. And if you notice, you have 6x and 4x. So one thing you could do, you have a lot of freedom here, by the way. I want to underline that. One thing you could do is you could multiply the top one by 2, and that would think ahead, that would make 12x after you multiply that. And that would mean you would want -12x on the bottom. Well, then you'd have to multiply this bottom equation by -3, because -3 times 4x would make -12x. Then you'll have your opposites. But I'm just going to say, some kids have told me over the years, they're like, I have trouble thinking like that. Like, when it's not obvious what to cancel, I have a tough time thinking about, well, what can I multiply by? So here's what I'm going to do. This is the tried and true, no matter what. You don't have to, doesn't really require any thought. And it's right here. If this is 6x and this is 4x, this is how you can always cancel your x's, no matter what they are. This is 6x, this is 4x. If the bottom one has a 4, I'm going to multiply the top one by a 4. And the top equation has a 6, I'm going to multiply the bottom one by 6. That way I'm going to get 24 and 24 guaranteed, 4 and 6, 6 and 4. But I do want one of them to be negative, and it does not matter which one, so maybe I'll multiply the bottom equation by -6. So now take a look at what this new system is after I do that. So I'm going to take that 4, and I'm going to distribute it to that entire first equation. That's the thing. Don't just do it to the x's. Right? That's the same rules of algebra we've always learned. If you do it to one piece of the equation, you got to do it to everything. So 4 times 6x gives you 24x. 4 times -5y is going to give you -20y. And 4 times that 14 is going to give you +56. In your bottom equation, -6 times 4x is going to give you -24x. -6 times 7y is going to give you -42y. And -6 times -1 equals +6. And so now I've got my opposites here with x's this time. So once you have your opposites, make a big underline, and let's add these two equations together. So 24x and -24x cancel each other out. That's what I wanted. My y's, -20y minus 42y, gives me -62y. 56 and 6 combine to give me 62. So now I've made this one new equation. My x is eliminated. To solve for y, I'm just going to divide by -62. Divide by -62, you get y is equal to -1. There we go, and now let's solve for x. So I'm going to plug this -1 into one of my equations. It could be one of the two original ones. It could be one of the ones that I made after I multiplied. It could be one of these two right here. Doesn't matter, because they're all, true equations that I'm working with, so it shouldn't matter. I always like to go into one of the original ones, though, so the numbers are smaller. So I'll go into that first equation, 6x minus 5, and in place of y, I'm going to put that -1 equals 14. So now I'm just taking that -1, plugged it in for y, into that first equation. And now simplify. Negative 5 times negative 1 is positive 5. 14, subtract 5 from each side. 6x is equal to 14 minus 5 is 9. Divide both sides by 6. And you'll get x equals 9/6. And 9/6 reduces. 3 goes into each. Reduces to 3/2. So there's your x value. Or with an ordered pair, that would be 3/2, comma, -1. That would be the two. That would be the point where these two lines intersect. And a great way to check is to graph them on Desmos or use substitution and see if you get the same answer. But there we go. That's it. That's probably the best method. And that one right there, took a little bit of work multiplying both equations by a number. Sometimes you have to only multiply one equation by something. And sometimes, like that first one, you don't have to multiply either. They're all ready to go as it is. So you got a lot of freedom, but remember, it's about making opposites, making things that are going to eliminate each other, cancel each other out when you add them together. Okay, so if you have any questions, just let me know. And as always, keep working hard, kids.